Hi, this is the Milestone update for realistic real-time rendering of real scenes using ray tracing. Basically, this is extending Project 3 to be much faster and look much better. So the first optimization we've done is texture baking, which basically saves the irradiance at every point on a diffused surface so that we can just sample that later instead of having to ray trace again. It's basically a pre-processing step that makes all future renders much, much faster. Then we can optimize that a bit more by actually rasterizing those baked textures using OpenGL, so we don't even have to ray trace it. And you can see in this that only the red pixels get ray traced, which was slowed down for the video, but in reality is much faster. And we can see that we can actually see the scene in the visualize mode. Next, we use that rasterization to actually perform the first intersection of every ray. And if we look at this, we actually color each primitive slightly differently, and then we encode basically the primitive number into that color. Then the ray tracer can go look up its first intersection just by looking at that color, and it speeds it up significantly. Next is adding in bidirectional ray tracing / kind of photon mapping. Basically, we shoot out in the baking phase, we shoot out rays from the environment instead of from the camera. Or yeah, and it gives us a lot better caustics. You can see the reflections on the wall are much better. And that basically only affects the baking part. The rendering part is still the same. So it just is reading the baked texture to get those caustics. And we can see the reflection of the sun off of the mirrored ball onto, like from here through the glass ball onto the wall is much, much, much better. And it just in a short amount of time gets a really good texture. Next are just some more optimizations we're doing. We only really do one ray per pixel. That gives us makes it really fast, allows us to just traverse through the scene in render mode in real time. We try and do as fast BVH traversals as possible, making it iterative and using SIMD and not basically doing any dynamic allocation. And it makes it very fast. You can see glass is a bit messed up when you do one ray per pixel because using just Monte Carlo method with only one sample doesn't look that good. So to fix that, we basically kind of do almost like an integration over the BSDF, which is basically doing the reflective ray and the refractive ray at the same time, like splitting up and having like a whole tree of rays. That kind of gets into the curse of dimensionality, but we don't let it go too far. We still have a reasonable maximum number of rays, and it looks much better. Then to make our things look a lot more realistic, we're trying to scan real scenes using 3D cameras and reconstruct that in the path tracer mesh, which is going well. There's a lot of work to be done. Basically, we need to scan an entire scene, figure out how to maybe simplify the mesh so that we can get real time, because currently a wall might take 10,000 triangles when it should only really take a few. And then maybe detect, right now it only does diffuse surfaces, but we could maybe detect transparent or reflective surfaces and add those in automatically, which would make it look very cool and use the capabilities of the ray tracer. So that's pretty much it. We do need to do, so to do is a lot of real scene reconstruction stuff, basically making it more automated, making it faster using mesh simplification. Then we also need to do maybe possibly hardware acceleration for ray tracing. The rasterization techniques already make it fast enough, and it would be a significant amount of work to translate the current ray tracing algorithm to like CUDA or something. So we don't know if we're going to do that. We still can probably make it semi real time without it. That's pretty much it.